Hi. In a previous video, we learned how important it is to hash user passwords before they are stored into the database. In this video, we're going to see how to do that. Here we have a server that is running, and it's got an endpoint that we can use to see a list of users. As we can see, there are no users registered yet. So let's go and register one. Go and register this user. We'll see that, oh, bad panda. See? The user password is stored in the database as plain text. And since we know that users are going to reuse their passwords across different applications, if an attacker gets a hold of our database of users, we have a problem in our hands, right? So what do we do for that? Well, we use a one-way process called hashing, where we take a user password in plain text and translate that into a string that you can no longer reverse back into the password. For that, we're going to use a little library called bcrypt.js. It's well supported in the community and is open source. So any vulnerabilities that are discovered are quickly addressed by the user base. Let's see how to do that. Going into our project, the first thing we need to do, of course, is install that library. So npm bcrypt.js. There are many libraries that do this, right? We're going to use this one because we know it's popular and it's been around for a while. It's well supported. Now that we have the library in our project, we could go ahead and import it here at the top. We're going to call it bcrypt. Bcrypt.js is the name of the library. And now what we want to do is, whenever we register a new user, right before we save it to the database, you can see that we're saving it right here. So right before that, we're going to take the user password, hash it, take that hash, and make it the new user password, and then we're going to store the user. So let's see how to do this, okay? Here we're going to say, I would like to get a hash. And this hash is going to be coming from the user password using the library that we just imported. So we call the bcrypt right at the top, right? This library right here. And it's got a couple of methods that we care about. For generating the hash, we're going to use the hash sync. And then we need to pass it the user password. And this is the user that is coming in the body of the request. We're grabbing the username and the password as user. Now, we can pass a second argument to the hash sync method to provide the number of rounds that the library is going to use when hashing the passwords. And this is important because this is how we slow down attackers from pre-generating hashes. The higher the number, the longer it's going to take to generate each hash. So you want to make this number as high as you can without making it too slow for the users. We're going to start out by making it 12. And 12 doesn't mean that it's going to get hashed 12 times. It means 2 to the 12, which is a really big number. And that number is the number of times that the library is going to take the original password, hash it, take the hash, and rehash it again, as many times as 2 to the 12. Once we do that, that's going to produce a hash, and we can grab this hash right here. We are using, notice that it's got a couple of methods with the same name, hash and hash sync. Hash sync is the one that we're using. It's going to do this synchronously. So none of the code that follows this line 21 is going to get executed until we have that hash. Now, after we have the hash, we can go ahead and say user.password is now equal to the hash, the new hash that we just generated. So we, in effect, just overrode the password of the user with the hash. It is okay now to go and save the user to the database. This should be enough to get the functionality that we expect. Let's go give it a try. Let's create a new user called Sam and give it a password of pass. Short password for demo purposes, okay? And this is what we want to see, you see? Now the password is no longer pass. It's a big string that has a few characters in it. If we could register another user, let me show you something interesting. Frodo, with the exact same password, we send that. And if we go and look at the list of users now, you would expect that the passwords would be the same, but they're not. And the reason for that is that the library will automatically add something called a salt, which is just a random string to the password that you provide, and it generates the hash by combining both the user provided password and the salt, which means that even when two users have the exact same password, the generated hash is going to be different. And this provides a little layer of security. In the following video, we're going to learn how to validate the password when a user is trying to log in. But for now, we know how to store passwords in a more secure manner.